Hello everyone, I am Zahid Abbas. In this video we are going to learn about what is derivative. Derivative is the essence of calculus. It is the instantaneous rate of change of a function with respect to one of its variables. This is equivalent to the slope or gradient of tangent line on the graph of a function at a point. First of all, we try to learn that what is meant by the slope or gradient of the tangent line. To understand what this means, think of a log on a curved surface as in this figure. If we draw a straight line passing along the bottom of the log, then this line is a tangent to the curve at the point of contact. But the problem is, it's not an easy task to draw an accurate tangent line at a point on a graph. It can have some amount of inaccuracy in it. So rather trying to draw a tangent line at a point, normally we draw a secant line that joins that point with any other point nearby on the graph. Suppose we have to find the slope of tangent line at this point P on the graph. We select another point Q on the graph nearby. Then we join these points to get a secant line. And then we find the slope of this secant line using two-point formula. That is, slope is equal to rise over run, and slope is equal to y2 minus y1 divided by x2 minus x1. This slope is not equal to the slope of the tangent line at point P. However, we can get a closer value by selecting the second point close to the first point. This value of slope will be more close to the value of slope of tangent at point P if the second point is more close to the first point. Suppose the coordinates of point P are x and y. Also suppose the coordinates of point Q are x plus delta x and y plus delta y, where delta x is very small change in x and delta y is corresponding change in y. As delta x and delta y are very small, it means the point Q is very close to the point P. Let's try to find the slope m of this secant now. M is equal to y plus delta y minus y divided by x plus delta x minus x. And m is equal to delta y over delta x. Name it as equation number 1. Suppose delta x is so small that it is almost equal to 0. So we can apply limit on equation 1 as limit delta x approaches 0 of m is equal to limit delta x approaches 0 of delta y over delta x. M is equal to limit delta x approaches 0 delta y over delta x. Name it as equation number 2. It is the most accurate value of slope of tangent on graph at point P. And this slope is named as the derivative. Let's try to learn about derivative in another way. Consider this equation. Y is equal to 2x. In this equation, if we substitute random values of x, we get corresponding values of y. Let's try substituting some values of x and get corresponding values of y. Y is equal to 2x. When x is 1, then y is 2. When x is 2, then y is 4. When x is 3, then y is 6. When x is 4, then y is 5. And when x is 5, y is 10. It may be noted clearly that in the equation y is equal to 2x, the value of y depends upon the value of x. Hence, variable x is named as the independent variable, whereas the variable y is called as the dependent variable. Moreover, each value of x corresponds to only a single value of y. In such conditions, we say dependent variable is the function of independent variable. That is, y is function of x. In the equation y is equal to 2x. Mathematically, y is equal to f of x. Hence, the equation y is equal to 2x can be written as f of x is equal to 2x. In the equation y is equal to 2x, when we substitute x is equal to 1, we get y is equal to 2. Let's add a very small increment in the value of x and observe the corresponding change in the value of y. That is, put x is equal to 1.01 in the equation y is equal to 2x and get corresponding value of y. Y is equal to 2x. Y is equal to 2 into 1.01. Y is equal to 2.02. Let's try x is equal to 1.02 this times. Y is equal to 2 into 1.02 and y is equal to 2.04. Note that each change in the value of x gives a corresponding change in the value of y. Let's deal it algebraically. The actual relationship between x and y is y is equal to 2x. Name it as equation number 1. Suppose change in x is delta x and corresponding change in y is delta y. Hence equation 1 is changed to a new equation. Y plus delta y equals 2 into x plus delta x. Name it as equation number 2. Subtract equation 1 from equation 2. Y plus delta y minus y equals 2 into x plus delta x minus 2x. Delta y is equal to 2x plus 2 delta x minus 2x. and delta y is equal to 2 delta x. Divide both sides by delta x. Delta y over delta x equals 2. Name it as equation 3. The equation 3 represents the rate of change of the function y is equal to 2x with respect to x. If we apply a limit on equation 3 such that delta x approaches 0, then we may get instantaneous rate of change. Limit delta x approaches 0 of delta y over delta x is equal to limit delta x approaches 0 of 2. Limit delta x approaches 0 of delta y over delta x is equal to 2. Name it as equation number 4. The equation 4 gives the instantaneous rate of change of the function y is equal to 2x with respect to x. And this instantaneous rate of change is the derivative of function y is equal to 2x with respect to variable x. The term limit delta x approaches 0 delta y over delta x is replaced by another term dy over dx, which is read as derivative of y with respect to x. Hence, we can conclude from above discussion, if y is equal to 2x, then dy by dx is equal to 2. It is read as derivative of y in the function y is equal to 2x is 2. And this was all about this video. See you soon with the next video.